As can be seen in this lateral view through the pterygomaxillary fissure, in life, the Pterygopalatine fossa is packed with nerves that serve several important functions. These include providing the innervation to all upper teeth and regulation of activity of the tear-producing lacrimal gland located in the superolateral region of the orbit. Two separate nerves enter the fossa. The purely sensory maxillary branch, or V2, of the trigeminal nerve, and the nerve of the pterygoid canal, carrying both the preganglionic parasympathetic and the postganglionic sympathetic fibers. The round structure visible within the fossa is the pterygopalatine ganglion. I'll describe it in more detail in a few minutes. Not seen in our model is the maxillary artery, a major branch of the external carotid artery. Within the Pterygopalatine fossa, the maxillary artery gives origin to multiple branches that accompany respective nerves. Let's now consider the nerves and their branches in more detail. We'll start with the maxillary nerve, or V2. It originates from the trigeminal ganglion in the cranial cavity and enters the fossa through the foramen rotundum. It then passes through the fossa and exits as the infraorbital nerve, seen here in light green, through the inferior orbital fissure. While in the fossa, the maxillary nerve forms several branches. They are the nasal, orbital, zygomatic, infraorbital, posterior superior alveolar, greater and lesser palatine, as well as pharyngeal nerves. Let's have a look at the nasal nerves first. Typically, there are 7 of them, but for simplicity, they are represented as a single nerve, shown here in purple. This nerve passes through the sphenopalatine foramen in the perpendicular plate of the palatine bone and enters the nasal cavity. In our model, the right lateral wall of the nasal cavity is clearly visible on the right. However, the medial nasal septum, found in life on the left, is missing. At this point, the nerve is referred to as the nasopalatine nerve. It extends anteriorly and down the medial nasal septum and passes through the incisive canal and then the incisive fossa in the hard palate. Although not shown in our model, there are actually 2 incisive canals, one on each side of the nasal septum. They then quickly form the single incisive fossa in the roof of the oral cavity. After emerging from the incisive fossa, the nasopalatine nerve supplies linguogingiva, mucosa, and glands adjacent to the upper incisor and canine teeth. The orbital branches, shown in dark green, are small nerves that enter the inferior orbital fissure to contribute to the innervation of the orbital wall and the sphenoidal and ethmoidal sinuses. The shown in blue zygomatic nerve also passes through the inferior orbital fissure. Although not shown in the model, the zygomatic nerve extends forward on the lateral orbital wall where it divides into 2 smaller nerves, the zygomatico-temporal and the zygomatico-facial branches that supply skin over the temple and skin adjacent to the zygomatic bone, respectively. We'll come back to the zygomatico-temporal branch in the context of innervation of the lacrimal gland in a few minutes. As briefly mentioned earlier, the shown in light green infraorbital nerve is the anterior continuation of the maxillary nerve, or V2, that exits the Pterygopalatine fossa through the inferior orbital fissure. Initially, the infraorbital nerve is located in the infraorbital groove in the floor of the orbit. It then continues within the infraorbital canal to emerge from the infraorbital foramen. While in the infraorbital groove and canal, the nerve gives origin to two branches, the middle superior alveolar nerve and the anterior superior alveolar nerve, respectively. Of the two, only a very short fragment of the middle superior alveolar nerve is visible in the model. The middle superior alveolar nerve innervates the upper premolars and the mesiobuccal root of the first molar tooth. The anterior superior alveolar nerve supplies the anterior teeth, both the canines and the incisors, as well as the corresponding buccal gingiva. The posterior superior alveolar nerve, seen here in white, first passes laterally and then through the pterygomaxillary fissure of the Pterygopalatine fossa enters the infratemporal fossa. It continues laterally and inferiorly and enters the maxillary sinus through a small alveolar foramen, located more or less halfway between the inferior orbital fissure and the last molar tooth. Within the maxillary sinus, the nerve continues inferiorly to supply the upper molar teeth, except the mesiobuccal root of the first molar tooth, and the corresponding buccal gingiva, and to contribute to the innervation of the maxillary sinus itself. Ultimately, the posterior, middle, and anterior alveolar nerves anastomose, or form a network within the alveolar process of the maxilla to form the superior dental plexus. The greater and lesser palatine nerves, depicted in blue-gray color, originate from the pterygopalatine ganglion and pass inferiorly through the palatine canal to emerge on the posterior aspect of the hard palate through the greater palatine foramen and the lesser palatine foramen, respectively. The greater palatine nerve passes anteriorly along the roof of the oral cavity to innervate the lingual gingiva of the upper molars and premolars and mucosa and glands of the hard palate. The lesser palatine nerve passes posteriorly to supply the soft palate. The pharyngeal nerve also originates from the pterygopalatine ganglion. It passes posteriorly, exits the pterygopalatine fossa through the palatovaginal canal, and emerges in the nasopharynx to supply local mucosa and glands. The nerve of the pterygoid canal is formed within the middle cranial fossa by the greater petrosal nerve, a branch of the facial nerve or cranial nerve 7, that carries preganglionic parasympathetic fibers, and the deep petrosal nerve that originates in the superior cervical ganglion in the sympathetic trunks and carries postganglionic sympathetic fibers. After passing through the pterygoid canal, the nerve enters the pterygopalatine fossa and continues anteriorly to join the pterygopalatine ganglion, the largest of the four parasympathetic ganglia in the head. The pterygopalatine ganglion is made by cell bodies of the postganglionic parasympathetic fibers that synapse with the preganglionic fibers carried by the greater petrosal nerve and the nerve of the pterygoid canal. The postganglionic parasympathetic fibers exit the ganglion and are distributed to their respective targets by the branches of the maxillary nerve described above. The postganglionic sympathetic fibers, carried by the deep petrosal nerve and the nerve of the pterygoid canal, simply pass through the pterygopalatine ganglion. There is no functional relationship between these fibers and the ganglion, and are also distributed to their respective targets by the branches of the maxillary nerve. Some of the postganglionic parasympathetic and sympathetic fibers that join the zygomatic nerve, and more specifically its zygomatico-temporal branch, are involved in innervating the lacrimal gland. While in the lateral wall of the orbit, these fibers form a separate autonomic nerve, which then passes superiorly to join the lacrimal nerve, one of the branches of the ophthalmic nerve, or V1, which itself is the most superior branch of the trigeminal nerve, or cranial nerve 5, to ultimately innervate the lacrimal gland. A lesion involving any of these preganglionic or postganglionic parasympathetic fibers may interfere with tear production by the lacrimal gland, resulting in a condition called dry eye, which potentially may lead to loss of vision in the affected eye.